we got a lot of content, so I want to get started. Thanks for practicing with this. This actually is really helpful because we're going to be using the system throughout the time today. So thanks for being here. Thanks to Alan and the Information Tech group. Today's session is on peer instruction with classroom response systems. I'm Dan Morrison. I'm here on the Seaver campus here in Malibu in Sociology. And I want to thank a couple people, again, the IT group, but also Derek Bruff, who is the director for the Center for Teaching at Vanderbilt University, where I had the occasion to give a version of this talk at the very beginning of my engagement with peer instruction, and several of the examples come from him. He actually has a book on peer instruction with classroom response systems or clickers, and so I encourage, if you're interested in that, I can give you that information. There's a lot of talk about this technology and some development even after Derek wrote the book, which is probably 4 or 5 years ago now, at the very least. So today, I want to do a few things. Introduce peer instruction as a teaching strategy, model some best practices with these response systems, and I'm going to call them classroom response systems and clickers kind of interchangeably. A clicker is actually a piece of hardware. It's a device. It looks like a little remote control. Often it has about 12 or 15 buttons on it, and students use those to select their answer key or their answer to a set of closed-ended questions, kind of in the same way you did with the question I had at the start. So if I say clickers and classroom response systems, I really mean kind of the same thing, and there's some different models and versions, and even a new one I want to show you later on today. So I want to have some time also to have you write and then pair up and evaluate clicker questions. So this is going to be you working as well as me up here. And then introduce some supports and discuss options for grading and thinking about how you might assess students with these systems, reasons why you would, reasons why you might not. So your next question is this: did you bring any of the following with you today? And I'm going to start the poll here. And so again, what you'll do is you'll text one of these codes to 22333. So if you brought a text-enabled cell phone or a smartphone, text 481-871-22333. If you brought a tablet with an internet connection, that's a number with a 2 on the end, and then laptop with an internet connection with a 3 on the end. Couple features of this slide you might see. So I've embedded this question in PowerPoint. You can also embed these slides in Keynote, these questions in Keynote. A couple other things about it, you might see on the bottom left-hand corner this stopwatch here. And so you can actually start and stop the questions and give students time. So if you only want a minute for responses, if you only want 30 seconds for responses, you can do that as well. And again, on the bottom right-hand corner, the number of results is showing up here. So I'm just going to show the chart. And as responses come in, the system builds this dynamic chart, right? So we have 3 responses for text-enabled cell phone, 5 responses for laptop with internet connection. Now 4 and 5, right? And you can show this as students are responding. You can hide it as I've done. You can ask, obviously, much more complicated questions. But this is a nice orienting question for me to see what kind of tech we have in the room. So if I know that I have a class of 100 and only 80 students respond and say I have one of these 3 kinds of devices, I know I can only expect then somewhere around 80 responses to my questions going forward, unless I purposefully ask students to pair up or somehow get into groups to pool their responses and talk to one another.
Can I ask what are you showing right now? Like, is that a PowerPoint?
This is a PowerPoint slide.
Okay, that's the PowerPoint.
Yeah.
Okay.
So what happens is Poll Everywhere, if you download their software, it actually floats on top of PowerPoint. Let's see. Next question is, how much experience, if any, do you have in teaching with classroom response systems? So again, same kind of system, same kind of question. Have you not used them at all? Are you just getting started? Are you comfortable with the basics? Or are you a power user of classroom response systems? And what I'm doing now is just watching the responses come in as people think about their answers here. And once we get to about 7 or so.
Okay, on the last one, if I sent multiple responses, are they supposed to be separated by commas or just one response?
If you send multiple responses, your response might not even be counted because it only counts the last response that you made. And you can actually set the system up to accept multiple responses. So you can say you only get 1 chance at this, right? Or you get 2 chances or 3 chances. Most of these I've set to unlimited responses, but the system will only count your last response. So if you decide, Michael, I'm not, that I'm just getting started, I'm more comfortable with the basics, you just key in the other number and it shifts your response from the second category to the third category. Now this is where, because there's this system, right, you can imagine if there are questions that you are trying to get your students to respond to and they actually matter in some ultimate way, you might get shifting responses, right? When people see that there's a tipping point that people are converging on one answer or another, which is why I like to hold off on showing those responses. Or if it's a really high stakes question, I don't encourage high stakes questions for these, but if it's a question that you're really interested in having students commit to their one answer and not being swayed by the crowd, you can just put in the one answer only. Just give them one shot at the apple, one bite at the
You
apple.
can't withdraw an answer.
In that case, you wouldn't be able to withdraw an answer. So if you set the system to say accept one answer and one answer only from each respondent, then
So I could not send another one from this. Well,
you couldn't.
know that.
That's right. Yeah. And you can imagine situations where you'd want that,
Yeah.
and situations where you wouldn't. Right. Okay, so we got some diversity of experience here, which is good. So those of you who are comfortable with the basics or who are power users, if you have insights to share, ways that you've used this technology, I welcome your comments on that. And I always like to find out what people's goals are. What are your main goals for this session? What do you want most out of your time today? Let's start the. Do you want to understand peer instruction as a teaching strategy? Do you want to learn how to use these response systems for peer instruction? Do you want to figure out if classroom response systems could help your students? Or you want to learn something else that's not on the screen there? And while you're doing this, how are you finding the system? Is it comfortable, easy enough to navigate, the instructions relatively clear? You think your students can do this? They're probably used to texting, many of them.
It's less comfortable than I had realized.
Oh, really?
Like, students are always complaining about it, and I always think, what's wrong with it? It's so easy. And then I'm like fiddling, this doesn't work, and this is my...
Well, putting you in the role of the learner is actually
doing it on a phone rather than on a laptop.
Yeah.
This is...
is part of the reason why this workshop works in the way it does, to give professors and faculty an insight into how this looks from the student perspective. So let's look at your responses here. So we're evenly split between understanding peer instruction as a teaching strategy and figuring out if this could help students. So thanks for that. And then no one said not mentioned above. Good. Okay, we're set. Awesome. One of the issues faculty perennially face is trying to engage students in deep, rigorous, engaging learning experiences. And those of us who study this or who think about this and use peer instruction and classroom response systems think that they can really help drive student engagement and learning in our classes. So could you name for me the most significant challenge you have in engaging your students in that deep kind of learning? Is it large class sizes? Is it students that want to speak in front of their peers? Is it they take notes and they don't engage? Are they too focused on grades? Or do you think it's that they don't adequately prepare for class? I should say most of the questions that I have here have 3 or 4 response categories, sometimes 5. but Poll Everywhere will accept a lot of response categories. Now, you probably don't want a lot of response categories because that can confuse you and your students. So I try to keep it manageable because there's only so much room on your screens anyway in the classroom.
Can I ask a question while we're waiting? You keep using the word, and I think in your title even it calls peer instruction.
Yeah.
What is it? I don't know that I know what peer instruction is. I know that learning management systems aren't designed for group work. They're designed for individual, not for peer instruction.
Yeah.
But yeah, you seem to be using those as synonyms. So
I don't consider Poll Everywhere a learning management system.
But I mean, Poll Everywhere is really hard to do in group work. I've tried. It's really hard to do here. You know, it's a one thing.
Well, we're gonna run you through an example of what peer instruction is, so that it'll become really clear. We're still in the. In other audiences, Cheryl, they're working us on baby steps through this.
Okay. No, I just was confused.
Let's see. Okay, so some focus on grades, some hesitancy to speak up, and a couple of votes for large class sizes and not preparing adequately for class. Okay. I have here a video about the folks up north at Harvard and how they have misconceptions, and it's really funny. But I don't think I'm going to show it just because it takes about 5 minutes, and I want to get to the meat of the heart of the matter, as Cheryl's saying. One challenge that we have in classes is to get inside our heads to try to figure out what our students actually understand about the material we're trying to present to them. And so peer instruction and classroom response systems is one way to surface the misconceptions, the misunderstandings, and really the gaps in knowledge that our students have. And if you look this up, it's called Private Universe on YouTube, and it's about how Harvard graduates think that the seasons are caused by the Earth traveling closer to the sun. That's what they think. It's not true. In case you were wondering, we don't have seasons because the Earth gets physically closer to the sun. And then it's not like winter, we're way far away, and summer, we're really close. That's not how it works. You'll have to watch Private Universe to get a better sense of that. But even Harvard undergraduates don't quite know why it works. So, peer instruction. If you're going to use this for your classrooms, you're going to often have questions that challenge students to think about the concepts and apply concepts from your course to an actual situation or to a real world example. And so, considering that a tiny acorn can grow into a mighty oak tree, which of the following contributes the majority of the mass to the tree? Is it soil, air, water, or sunlight? So text one of these codes to 22333. You'll notice with classroom response systems, everyone who has a device can participate. So even in our most successful lecture classes, probably only 20, maybe 30% of students interact and actually talk with the professor. And of course in our smaller classes it's a little bit better, but I have a class of 13 students this semester and I haven't heard from about 2 of them. And so I'd like to hear from them because I think they probably have good things, important things to say and to contribute. But if I don't hear from them, I don't know. And also I can't surface the misconceptions that they have. And so doing anonymous polling like this can help me surface misconceptions and misunderstandings that they have. This also, in the course of a lecture or a class, can be a quick assessment, again, to identify those misconceptions, but also if there's a major problem where a lot of students aren't understanding or answering the question correctly, I can then reframe and switch up my teaching so that we cover something that maybe we covered last time that they're not remembering, and really jog their students' memories so that they can answer questions much better. All right, let's look at your responses. Okay, soil, air, water, and sunlight. Awesome. Awesome. What I'd like you to do is turn to your neighbor and discuss your answer. There's some disagreement here. So turn to your neighbor and discuss your answer. And if you have conflicting answers, I want you to argue about who is right. So let's do that for a couple minutes. So turn to your neighbor and try, if you have differing answers, try to convince them that you're right.
What if we understand?
As I say, I can't really make a strong argument. I really guessing.
So is there any because you're just talking about the process.
So even if you have the right answer, it's a good idea to talk to your neighbor and to explain why your answer is the right one. And I'll just tell you, many of you do not actually have the answer I'm looking for. Many of you do not have the answer.
So it's not water.
Because I think and I know that when you put them in soil, the soil doesn't like disappear. You know, you plant them and the plant will grow without the soil disappearing. So it's clearly not like taking the soil. And sometimes how do we matter? That's the process of elimination. Water doesn't disappear when you feed it to plants. That is my.
You don't know whether the air is.
That is true. I wouldn't have a way of measuring that.
Where's the person here? Like off the top of their head. This is
I have to have diverse examples. It can't be all about.
There's a little whining.
Is this question too hard? This is a question.
Sir, we haven't studied this yet. Is it on the exam?
It's totally on the
That's not
exam.
fair.
It's totally on the exam. Okay, so I had a chance to discuss it, and as I said, many of you do not have the answer I'm looking for. Many of you do not have the answer I'm looking for. So now since you've discussed it, maybe someone has convinced you that your answer is not the right answer, or maybe my little push by saying that many of you do not have the correct answer has changed your mind. So what I'd like you to do, I'm going to clear the results and open the polling again, but I'm going to hide it again. So now you've had a chance to look at the question, you've committed to an answer, you've discussed your answer with a peer, and now we're going to re-poll to see if that discussion has had any effect in helping you come to an answer that is more correct.
Just remember, this is not the volume of the tree, it's the mass of the tree.
Yes, it's the mass. So this is a question about mass, about what is mass, right? That's the sort of underlying concept that this question is trying to get students to understand. Of the things in the natural world, how do they get their mass? What is that mass made up of? That's the question. This is actually not a trick question. I've used this many times. Dr. Bruff has used it as well. Typically with really smart audiences such as yourself, there's controversy that breaks out. Because
Controversy about ignorance, okay.
well, it happens. It happens.
Sounds like Congress. Anyway, I didn't say that.
Okay. Any last responses? We've got 6, 7. And sometimes I like to put up that countdown just to give it a little sense of urgency.
The countdown, the timer?
Yeah, the timer.
Oh.
Yeah. Okay. Now there's some different answers, right? Air has gained 2. Soil, I think, maybe gained 1, right? Water is still in the lead. Sunlight dropped out, so someone was convinced that sunlight is not the correct answer. So for those of you who said soil, what is your thinking? What's your thinking there? Justify your answer.
I had heard one argument from one of my peers said the soil is what provides the nutrients for the acorn to reach its full potential. So while it knows what it may need in its DNA to grow and fully become this oak tree, it can't do that without the necessary fertile environment to do that, and that the soil provides those nutrients.
Okay, so soil provides nutrients for the tree to grow and do its tree things. And so you're saying that the majority of the mass of the tree comes from those nutrients that then comes from the soil. Does anyone take issue with Landon's explanation? Landon takes issue with it.
I do, because that was my initial explanation.
Okay, but so Landon was convinced, or at least was temporarily convinced. So does someone else have a counter argument to Landon? Someone says, Landon can't be right because my choice has to be right. How about someone who chose air?
Okay, I picked
Ellie?
air.
Ellie picked air. So Ellie, why is it air and not soil?
Well, I guess I was having a little bit of trouble with the, contributes to the majority of the mass. Like, you'd say, okay, soil contributes to the mass because it helps the tree grow. Air, water, sunlight, they all help the tree grow. But it's hard to say this helps the tree grow more. So I thought maybe it meant what's the tree actually consist of. And
Right.
I first
Yeah.
picked water, and then I got the impression that wasn't right, so I switched to air.
Okay, so remember the question is about what contributes the majority of the mass of the tree, right? So it's not what helps the tree grow necessarily, but what contributes the majority of the mass. So Ellie, can you explain to us why air might contribute the majority of the mass to a tree?
I'm not sure.
Okay, so
I'm still,
can anyone help Ellie out?
I guess it's more space than the water. I don't remember. Yeah, somebody help me out.
Maybe the carbon dioxide that's inside of the air, since that's a vital nutrient for the tree, allows it to convert the nutrients that are in the soil, or convert the nutrients in the water into, or convert the photosynthesis from the sunlight into actual mass. I don't know how that exactly works. I know that's kind of like the tree equivalent of breathing, but I don't know how much that involves actually bulking the tree up with extra mass.
Right, okay, so Landon, gets us really close to where we want to go. So air consists of several compounds, right? It has mass, so it has carbon, it has oxygen, it has nitrogen, it has a bunch of other stuff. And what does photosynthesis do?
Convert sunlight into energy for the plant to grow.
Right, that's what it does. And what are the byproducts of that process? What do we get when plants breathe?
Oxygen is a byproduct.
When they exhale, we get oxygen.
Mhm.
So the air has nitrogen and carbon in
So
it,
the carbon
and
goes
oxygen
into
in it.
the-
Where does the carbon go?
It's absorbed as mass.
The carbon goes into the mass of the tree. You're right. So the majority of the mass in the oak tree is actually from the air, right? So part of the respiration process of the tree is exchanging the carbon dioxide in the air for O2 that the rest of us get to breathe, right? Thank you, Landon. Thank you, Ellie. Let's take a step back and look at what just happened. So I posed this question, this challenging question about where the majority of the mass of a tree comes from, and you answered that question independently. right? You sat there and you typed in your code. Then I viewed the results, and in this case, I allowed all of us to view the results all at the same time, right? And from there, about 3 things can happen. If most of you had answered correctly, I would have said, you know, congratulations, gold stars for all of you. You understand how mass works relative to trees, and we would move on to the next topic, right? On the other hand, if most of the respondents answer incorrectly, then I know I've now tapped into your heads and found out you don't know something that we think, or I think, is important for you to know about mass and the respiration cycle of a tree, right? Let's say I'm an ecology professor or something. So that I can then backtrack and say, you know, remember last week or last time or whenever we talked about the cycle of exchange of gases in a tree, you know, just like I did with you, Landon. So what's left behind when a tree breathes in CO2 and breathes out oxygen? Well, carbon is left. You know, we burn trees because they have carbon in them, and that makes us warm, right? And if students are split, like you were, right, there was no agreement about what the correct answer was, I had you discuss. And once you discussed, at least 2 people came up with air as their preferred answer. And then we unpacked that, right? So then I led this discussion with all of you about why air would be the most correct answer from among these options, right? And it had to do, you know, with, of course, the respiration cycle in the tree. But this slide encapsulates the peer instruction model. It's not the instructor standing up and explaining to you in great and often minute and terrifyingly boring detail the respiration cycle, but getting you to discuss and defend and reason through the respiration cycle in the way we did, you two did in your group around air, and then we did collectively as a class. So the classroom response systems allow and occasion what people who do some of this stuff call times for telling, which gives students the opportunity to explain and elaborate on their answer to their peers, identify mistakes and misunderstandings, and then correct those in a way that, hopefully, if it works really well, is helpful to the class, right? So typically, right, you came in cold, so you hadn't read about the respiration cycle, right? But when I use this in my classes, I often write 2 or 3 questions about the main themes of the reading and then have students argue and discuss those points. Let me check.
Can I just add one thing to that?
Yeah, sure.
Because this is, I think this is a technique that we all do, whether or not we have learning management systems and Poll Everywhere and stuff like that. But using this makes it much easier to do it in a big class. And I'm just comparing, because I'm teaching practically the same class to 170 that I taught to 40. Last year I did all the same things, but I would just be like, okay, what do you think? Raise your hand, then get into groups, discuss it. And now we use it on Poll Everywhere. And it works with a lot more people.
So if you were to download this presentation, which I encourage you to do because I'm going to upload it to the IT website, there are 2 videos, both from the University of Colorado, talking about how CU has integrated clickers into their science classroom. And the students there say that the questions they enjoy most are the most conceptually challenging questions. So they're not simply the questions of, you know, did you do the reading or not, or, you know, what's the 3rd word in the title of this article, right? Those are boring questions that you can just speed through. Students really like the questions that are actually most challenging. They get them into get them thinking and talking with their arguments, defending themselves, defending their positions with their peers in the class. So I'm going to breeze through these and give some examples of different types of clicker questions that you could use in your classroom. And many of these are mentioned on the handouts that you have in front of you. So for example, some of the easiest ones are factual recall questions. So which of the following is not a characteristic of Romanticism? Is it attention to the natural, the valuing folk literature, strong geographical center in Dusseldorf, referred to the blue flower as a central symbol for longing, or valued medieval literature and art? while you're clicking in there, I should say this Colorado video illustrates that some of the professors use these in labs to have students predict the result of experiments. Some of them use them to ask students what the next step in writing an equation or solving an equation is. And so you can use these and use mathematical notation in them as well. Students then can be asked to explain the reasons why they chose their response and how they reason through the answer about what would happen next. What happens if you put vinegar and baking soda together, right? Fizzes up. Why does it do that, right? Factual recall questions, of course, are useful for helping students, recall basic facts about the things that they read or the course concepts. They're often used to see if students did their reading, remember important points from prior classes, or have memorized key facts. There are just certain things in our classes that we want our students to just know cold. And questions like this one can help us pretty quickly get to the point of understanding who knows it, who doesn't know it, and then if need be, you can go forward with some more discussion. Okay, let's look at your responses. So you're totally split, which would be awesome, right? If we're in a class on romantic literature, we would be able to say, those of you who picked number 3, what didn't the Romantics like about medieval literature and art? Why did they not draw on those sources for inspiration? Right. The answer I have here is had a strong geographical center in Dusseldorf. That, as far as I know, that was not a key component of Romanticism. The questions can get more complex and have to do with actual science. So let's say your sister-in-law calls to say that she's having twins. And assuming she's not having identical twins, which of the following is more likely? Is it twin boys, twin girls, one boy and one girl, or all of those options equally likely? This is a question that would uncover students' confusion about the genetics of non-identical twins. It's a type of conceptual understanding question. And these questions assess student learning of important concepts. And the answers, if you write these correctly, write these cleverly, have really good distractors, right? They have distractors that are close to the right answer, could be argued for, but are ultimately incorrect. So you can ask students with conceptual questions to categorize, classify examples, match characteristics with concepts, select the best explanation for a concept, or translate among different ways of representing an idea with these kinds of questions. Okay, so I'm going to mute the picture for a second and look at your responses, because I want to see how you're doing here. Oh, good. Okay. Any more responses? Because I do want to get you to talk about this one, because I think it's worthwhile. As a twin, I think it's worthwhile for people to know this. Although I'm identical, so the question doesn't apply to me, but personally. Okay. Okay, so I will show your answers. And I'd like you to try to pair up again with someone close to you, and hopefully you'll have differing answers. But even if you have the same answer, explain to the other person why that answer is correct.
So an identical twin is the same zygote
That's the same thing, that's why I said, when I realized I don't know that.
non-identical.
The genetics
Okay.
behind it or biology, just purely statistical question.
Well, this is a statistics question, right? And it's a genetics question. It's about which of these, again, given that they're not identical. So identical twins, what's the special thing about them, right? It was one egg that then split, which means they're exactly the same genetically, and then they went on their own developmental courses in utero, right? Non-identical twins, fraternal twins, are two separate eggs that are fertilized, around the same time and then develop in the same maternal environment, right? Okay, so we'll do a quick re-poll to see if anyone changed their mind. Oh, sorry. Yeah. So key in one of these results here. We'll see if anyone. Oh, did I not start?
Yeah, you did.
Yeah.
It's coming in. Oh, is it coming?
Results are going.
Why does it say start this pool
Okay, so 7 responses again. It looks like all are equally likely lost some steam. This was the same, right? And then that was the same too. So those of you who said all are equally likely, what's your thinking there?
Well, they're not, so there's an assumption that she's not having identical twins, and the other type of twin, I always thought it was fraternal. Did you say paternal?
No, fraternal.
Fraternal twins could be 2 boys, 2 girls, also could be 1 boy and 1 girl. That's what I thought, so I felt the last answer was correct.
Okay.
I was thinking of it in terms of kind of like a coin toss, where if you flip one coin and it's heads or tails, and then you flip a second coin and it's heads or tails, since you only flip twice and there's only 2 possible outcomes for each one, it seemed like it was all about the same in terms of hitting heads twice, hitting heads and tails twice, or having a boy having a girl, but I don't know.
But I think, I was on the same track, but maybe a slight variation. I was thinking that with the coin toss thing, it's true, any given coin toss, it's a 50-50, but the chance of getting the same answer twice goes down, is less than.
Right. So Connie, did you choose 1 boy and 1 girl?
Uh-huh.
Right. Because sometimes it's going to be 2 heads. A quarter of the time it's going to be 2 heads. A quarter of the time it's going to be 2 tails. What about the other 50%? The other 50% it's going to be head tail, head tail.
Yeah.
So it's actually 4 flips of the coin, right?
Uh-huh.
In 2 of those flips, you get girl, girl, boy, boy. In the others, you get boy, girl, boy, girl, right? So what is that? That's 1 boy, 1 girl is twice as likely as both girls, both boys. So Connie we truncated the example a little bit because of time, but you can see how now we've allowed Connie to say, I think your thinking is a little. The metaphor is nice. The coin flip metaphor is good, but you didn't take it all the way, right? To see the full implications of your line of reasoning, right? And so Connie got to teach you, right? I stood back. I had a pretty well-designed question, right, that gets at this concept of genetics and twins, and you worked it out, right? There are many other examples we can show, or I can show. But I want to give, and also there are student perspective questions, there are conceptual questions, there are argumentation questions. This is one that someone from University of Texas, Austin, gives her students, which of these do you believe about human evolution? But I want to give you some time. So just individually, write out a couple clicker questions. Write out a couple questions that you think might be worth asking your students in your own context. Now that we've ran through a few examples and you've seen how the process of peer instruction actually works, are there questions that you think you might be willing to ask your own students? And so jot down that question, and then maybe a few options, and we'll talk about those. Give you about a minute and a half to jot down those questions.
So are we posting the questions someplace or just writing it?
Just jot them down.
I was saying that last night in my class that I teach, I had given the class 4 little vignettes, and one at a time, and it was just, is this like scope for license and scope of competence and scope of practice. So I gave them again, and they had to figure out, and then of course there were twists in it that make them think it might be this when it's that.
Good distraction.
But we did that. I don't use any electronics right now in the classroom. Alan is my rock because of learning how to do
Alan's my rock,
things.
too.
Yeah. So I'm figuring what are the little places that put that in, and that was a perfect example of this kind of thing where at the end of the class, when I usually have some kind of interaction where they have to meet in small groups, solve something. So that was good.
All right.
Because, you know, my class goes till 10, they're tired at night, so I have to be in.
All right. Well, thanks for writing those responses. Does anyone care to share their question, and we can workshop it a bit? Tell us about what your question is and what work that question does. You think it will do in your classroom. Yeah, go ahead.
I was thinking about using this for counseling center outreach and prevention programming kind of thing. So I was thinking like, my question is, what would you do if a friend told you she was so sad that she can't take it anymore? And then I have options like, ask your friend if she's thinking about suicide, explain that you feel the same, tell your friend things are going to be okay, or pray.
Those kinds of things.
So I was thinking,
Figure out
it'd be interesting to see where people start.
Right.
And each one of those distractors or answers would bring up good discussion, I think.
Sure. And that's a great example, Connie, because it works. Some of these questions don't have to have a clear-cut, right or wrong answer. In the show, I have a slide on Hamlet's response after the death of Ophelia. Right. This is a question that people who study Shakespeare have been asking a long time, right? And our classes, our students are great. They may not have the final answer to this question, and that has to be okay. In the same way that there are probably better or worse answers to the question that you give, but also you could then track change in your session. So you have a pre-test and then post-test. Often you might start a class period by asking students a really conceptually challenging question, maybe about computation or about something they're actually going to learn or develop in class that day, and then at the end you show that question again and you can compare pre and post. I mean, that's a really tangible sort of thing for you as a faculty member to say, here's the value added. Before 95% of you had no idea what the democratization process, and I don't know what some country looks like, right? But now you can explain how that worked, and you can give me a cogent reason why, you know, this person decided to do this thing, right? That's a great example, Connie. Anyone else? Be brave. Yeah, Cheryl.
A question that I was planning on using in class today, but ran out of time. And I didn't do it as multiple choice, but now I'm thinking of doing it your way. And it was more like a role playing. We're talking about imperialism, so you're whatever, an advisor to a king, and you're an explorer who's just discovered an island, and you know, this is the age of imperialism, colonialism, and it has gold, and do you take it or not? Or something like
Yeah.
that, and so, and why, or what do you advise the king to do? And so my original thought was make it a short answer and have them like think of a scenario, like what would you do? But it would be really interesting at the beginning of the class to say, you know, just here are some black and white multiple choice answers, and then go through what are some of the stuff that actually happened in that era, and then at the end, now think through it again, and would it change? Would your views change? I mean, that's just a cool way of looking at it. I didn't have that.
It would be a nice it'd be a nice reveal to have, you know, let's say Napoleon has this challenge, you know, and he's like, you know, should I put soldiers here or there? Because this happens, right? You have limited resources, and so, you know, what should you do? And then in the class you reveal what Napoleon actually did, right? And then the consequences of that decision, which would be really nice. Cool. You're good at this. All right. Awesome. The question often comes up, should I use classroom response systems or clickers in grading? And if you use the hardware systems, often those systems can be registered with the polling company. So I have a set of Turning Point clickers, that's one of the companies. And in theory, I could have students register those clickers, and then they can use it for attendance or for quizzes or for just any sort of purpose like that.
Can I just clarify, Poll Everywhere does that?
And you can,
I
yeah.
do that in my Elkins class. They all.
And you can also have students register their mobile devices in Poll Everywhere, right? Some pros to this would be that this data is really easy to collect and analyze. After every class period, you can download the data. You see who was in class, how they responded to the questions. You know, maybe you could make them low stakes, and it's not that big a proportion of their grade. Of course, students may be really motivated by grades too. So if you have those students who they feel the need to be rewarded for their reading and for their analysis of your questions, then you might throw them a few points. Also, you can track changes in student performance over time. So you can see how a student is either getting better or maybe not so. You can identify problems then also. So if a student is doing really well at the first few weeks, but then tends to not show up in class or has difficulty with some of the more conceptually challenging questions, even if they're low stakes, you can identify that student and then perhaps do some kind of intervention, which is really nice if you think about it that way. There are some cons, some potential downsides to grading with clickers, and the first one would be students might see these questions as punitive quizzing. They might look at the questions as a way to punish them for not having done the reading. And that's not how we want our education to be. We want it to be rewarding, not punishing, right? Also, students may have less incentive to share their answers and discuss course concepts in class. So if the clicker questions are an important component of their grade, I might have less incentive to help Ellie or Cheryl in my class or Landon than I would otherwise. If they're lower stakes, then I don't have so much fear about my expertise being used to help some other student get a better grade. Now, I know our students are all pleasant and high-minded when it comes to these things, but this is a fact of life. The other thing is, if you do use those hardware devices, then they're really easy to share. They're portable. They're meant to be portable. And so it could encourage clicker sharing, which is, you know, if I don't come to class, Ellie will carry my clicker in for me and ring in for me. So you want to avoid that as much as possible because that undermines the peer instruction model just at its core, right? I want to just share with you a couple things. The system we use today is Poll Everywhere. You can they allow you free accounts for up to 40 respondents per question. And then there's monthly pricing after that based on the number of respondents that you have. And it's not terribly expensive. Social Science Division has a has an account. That's why it was polleverywhere.com/essery. And as you can see, it works pretty well. It's nicely integrated into PowerPoint and then again into Keynote. There's also a relatively new product from Eric Mazur, who is one of the pioneers of the peer instruction model. He's a physics professor at Harvard, and so he has some collaborators, and they have this new product, Learning Catalytics, which has just now been rolled out to a few universities. It's really sophisticated and relies on seating charts that you would upload into the system for each classroom. And what it does then is assigns students to instruction groups or to peer groups, to discussions based on their answer to the question relative to their seat in the classroom. So for you, right, some of you had the same answer to these questions, and discussing that answer wasn't as productive necessarily as having an argument or a discussion with someone who has a different answer. This system would take care of that by optimally matching students based on their responses and their locations in the classroom. So instead of saying, if you did answer A, go talk to someone who has answer C, and maybe that person's way across the room, the system will match you up, and you can use it on tablets and on iPhones and on laptops as well. And I just want to show the video that Learning Catalytics put together, because I think it's interesting to see how these kinds of systems are evolving from a web-based and a text message-based system to a more robust and inclusive kind of system. So this will be the end for me.
In this introductory screencast, I'm going to give you a quick overview of how to use Learning Catalytics in your classroom. So let's create a course. So I'll create a new course here. I'll enter the name of the course. Then I'll pick the classroom. So these classrooms can be set up beforehand. And I'll create the course here. And now everything is organized around lectures. So let me create a new lecture. This is where I'll create my questions. So I'll create a new lecture here. I'll pick the date that it's going to be delivered on. And now I can start adding items. And items are just questions that you ask students. So here, let me just create a standard multiple choice question. So this will be a question about metal and what happens when it expands. And what I can do is I can upload images. So I'll just hit select files here and upload an image. And then I can just drag and drop the image into the prompt box to add it to my prompt. And there's many kinds of questions you can have, but let's just make a multiple choice question for now. And we'll just enter the choices that students will have. So it increases, it decreases. And here I can move the choices around if I want, move them up or down. I pick which ones are correct. And I can also type some text as an explanation. And this is what students will see after the class. When they log back in, they'll be able to see all the questions that were asked and what the right answers are and what the explanations are. I can also write some notes to myself. Let me save it, and let me add a second question here. So this question will be a sketch question. I just want students to sketch a graph of a function. And they'll sketch it using their mouse to click and drag, or they'll use their finger on their touchpad. Notice I can put formulas inside dollar signs if I write them in tech, and then they'll render as nice mathematics. So I'll create a sketch question here. So students are basically going to draw on top of an image. So I'll upload an image of Cartesian axes here. And I can pick different colors for students to draw on and all of that. But let me just save this question now. Okay, now I've created two questions. So I'm going to save the lecture. And now let's see what it's like to actually deliver the lecture to your students in class. So what I do is I'll start a new session. And what will happen now is you'll see a window pop up that will be the student view. And if your computer was connected to a projector, I would take this window and drag it onto the projector screen. But for now, let's see what happens when I try to actually ask a question. So to ask a question, I just click the Deliver button. And the students will see it on their student view. They'll also see it on their devices. And on my screen, I'll also see a graph of student responses as they come in. So let's switch to see what happens when a student logs in. And if you want to try this out, you can take your mobile device pointed at learningcatalytics.com and log in using your instructor account. And then you'll see exactly what a student would see, and you can even respond to questions like a student would. So a student uses their iPhone or their iPad or laptop, whatever device they want, and they enter this class session ID. And then we ask them where they're sitting. And so this is based on the classroom configuration you set up in advance. So as a student, I just pick my seat like I would pick an airline seat, or I can enter the number of the seat. And once I do that, I'll see the first question. So let me answer the question. I'll say it increases. And now after a few seconds, students will see the response that they put in, but they'll also have the response hidden for privacy reasons. So let's go back to the instructor view. So now I see there's 2 students logged in, and I see half the answers are A, half are B. I can click the seat map button to see where the responses are around the room. And now let's say I want students to discuss their answers. So I'll click Assign Groups. And here I can create groups for peer instruction based on some grouping policy that you can set here. Once I do this, I'll see the round 1 and round 2 responses side by side, so I can see if the student responses change before and after discussion. Now we can go to the student view, and we can see that students get a personalized message telling them who to talk to discuss their response, and they also get a chance to respond again. So when students respond a second time, on the instructor view, you'll see side by side the round 1 versus round 2 responses. So let's stop the delivery of this question for now. When you're ready for students to see the results, you can click Show All Results, and then students will see the results both on the screen and on their own individual devices. So here in the student view, we can see students see the results both for round 1 and round 2. Students have access to these buttons, I get it now and I still don't get it, which is a way to send the instructor asynchronous feedback. So now let's try delivering a second question, this sketch question.
All right, I'm going to stop it there, but you can see the evolution of this technology, right? From hardware-based systems to text messaging and internet-based systems, and now to a really robust system that integrates and is campus-specific, right? That sorts students. You can then, for learning Catalytics, you can then download all this data and then do tracking just like you could do with the questions that pull everywhere. But obviously, this is much more robust in terms of planning whole courses and lectures over time. So you can imagine a professor using this kind of system to set up all of his or her class sessions. And some professors actually, and Missouri is a great example of this, uses learning Catalytics and peer instruction as the instructional model for his class. So his students will go and they'll read the chapter and he'll test and assess their knowledge and help them work through the concepts together in class. And that's what they do. His classrooms are very active for this reason. So thank you very much for coming and for learning a bit about this. I really appreciate your time, and thanks again to the IT people, and thanks again to Derek Bruff. And if you want more information, just let me know and we'll talk. Thanks again.